Hello and welcome to our to this video demonstration of our robot launcher and fleet manager. So let's get started and launch the robot fleet launcher. Let's see, multi robot sim, and then launch a GUI.launch. So this launches the GUI of the launcher itself, and in here you can see a predefined list of robots already. So let's first clear that so we can have a clean slate. And let's get started with what actually this program or this launcher does. So you can define robots with a specific ID, navigation stack, robot types, for example, Ridgeback or Husky or Rosbot, um, and a docking station, so a position in the map in Gazebo where it will be positioned upon launch. So let's say we want to add a Ridgeback with ID 1. We want to use move base instead of SFM and PDM, and let's just keep it all at docking station 1. Click add robot, and it's added to the launch list. Say I want to add a Husky with ID, I don't know, 8, also at docking station 1. It's also possible. It's added with move base, and let's say I want to add a Ridgeback again with ID, let's say 1, which will conflict. At docking station 3 it will say it's not unique, sorry. So let's go for Ridgeback 2 or whatever, 13, and add it. So these are now part of our fleet, and we can add more or less if you want to. You can even delete the ones you already have or clear it all into one. And let's say we want to define the docking station, so these positions. You go to the docking stations tab, you select whatever docking station you want, and you can change the X, Y orientation inside the map. You can also change the spacing of the robots in the docking station. So if you have multiple robots per docking station, like we have here, docking station 01, docking station 01, you can say how far you want them spaced and at what angle they should be positioned. And you can also define the rows and columns, how they should be spawned. So next up, if you have this configuration done the way you want it, you can of course save it or load a previous one or even start all over, whatever you like. I'm not going to save this one. I'll just keep it like it is. Next up, you have the launch options. So of course we want to launch Gazebo GUI. So in the background it will launch Gazebo simulator, but also the GUI, which makes it visual. We want to launch the modular RViz, which launches with the specified robots in there already. So however many robots or few robots you have with move base or Ridgeback or Husky, RViz will then be launched with the right configurations for each robot. And of course we want to launch our fleet manager as well in this showcase. So next we click on launch. And as you can see, it will launch in the background everything that we've set up. So we can take a look at whatever it's still launching. All right, so let's see, it's still going on, but we can already check out Gazebo a little bit. So what you can see is we have the specified Ridgeback and Husky at docking station 0, 1, and we have the second Ridgeback at docking station 0, 3. So that appears to be over here. In the meantime, you see you cannot change anything because that would conflict with what you have launched. So, but you can of course click shutdown. Let's not do that for now. Next up, you have the dynamic RViz. So here you can see the map that is being launched with the robot as specified. So the difference between Gazebo, you probably noticed, but the difference between Gazebo And RViz is the Gazebo is the simulator. It does the physics and also has a view of course. But RViz actually shows doesn't do any physics. It's just a visualizer, a robot visualizer RViz. And in here you can, for example, specify the locations or show the location. Sorry, show the advanced Monte Carlo localization. So those are these red arrows. Once they move, this red arrow field will shrink, meaning that the localization is more secure or certain about where the robot exactly is, because each point is a guess where the robot is actually in this map, and that's based on the on this map and the lidar scan. So another point to show is the move base we've selected for all of them, as you can see here. And this move base is what determines how the robot will navigate to, for example, assembly station number 2. And you can see the path of the move base once there is one in green because of these global and local path options. Next up is the fleet manager. So right now there are no jobs, but of course there are mobile executors. So that's the robots, these mobile robots we have right here. And you can see Ridgeback 13, Ridgeback 01, and Husky 08. They're all on standby and they have no job assigned. So to assign jobs to them, we first need to create jobs. And to create jobs, we first need to place orders. We have a few orders in the list already. We can clear this, of course, by clicking clear list. And instead, we might want to create a new one or a few of them. So let's say we want a move with critical priority. We want this to be done immediately. And we want it to move to location 04, which I think is assembly station 2. And let's add that to the list. It was accepted. If we instead try to add something, location 04, location 02, that's too much arguments for a move command because you can only move to one and it will not accept it. So we can also, of course, add a location 02 move and make that medium. And let's say a transport order, make that high and say location 01 to location 01, location 03. So transport order is move to a location, get loaded, which is one of the other orders, then move to a location, another location and get unloaded. So now we have a few orders. Let's also just do a load order, which is low priority. And this one doesn't require any arguments, which is specified already, no arguments. And let's see. Yeah, there it is. Okay, and now we want to place these orders. So now they are sent to the job manager in the back. All orders are placed successfully, so that's nice. You can also see these orders coming in the job manager. And they've been added in the fleet manager over here. So you can see job 004, 003, 002, 001. You can filter on priority or on keywords, so load, move, transport. See if it's pending or active, the assigned mobile executor, and how many tasks are part of a job. So, of course, the transport order is a bit more complex, so it has several tasks, move, load, move, unload. The others are a bit more simple. And as you can see, now that in the background, one of the tasks has been, or jobs has been assigned. So we can see Ridgeback 13 being assigned to move to a location. And the reason it was assigned is because it was closest to the location already. So in the background, the orders or the jobs are assigned based on priority, and if it's a move order or transport order, also based on distance towards the goal. So say if the robot was here and there was a robot, or say the robot was here and there was a robot over here, this one uh, would be closer as in a straight line distance, but because it has to drive around, it probably would pick this one first. So now we can also see the Husky moving. Let's see what it was assigned. The Husky is executing job 003, which means it got assigned the transport order. And you might notice that it's all very slow. That's because my laptop is not quite up to spec for this simulation. So it's simulating a tenth of the real-time speed. So they're, yeah, quite slow. Okay, let's see if I've missed anything. Nope, seems to be about it. So robots are moving, orders have been placed. Once an order is executed, I think this one is almost at the right position. Yeah, then it will get uh, an update, and then the order will be removed once it's completed. So you can see in the meantime the third ridgeback or the second ridgeback, the third robot has been assigned a job and is now moving towards assembly station 1. And you can also see that the vector field of arrows for the advanced Monte Carlo localization is now shrinking because as the robots are moving, they get more certain what their actual position is and orientation. So in the background, oh, sorry, let me quickly get this. Yeah. So in the background, you can see what's happening. It first appended all these jobs in a job builder, then allocated the top one, so the first one, and this building is again based on priority. And you can see Ridgeback 13 was assigned a job, it's processing it. And same for the Husky and the Ridgeback 01. So it's almost reaching now. So let's see if we receive the job completed input. It's quite slow, so sorry about that. In the meantime, the Huskies almost reached its goal, and so did the Ridgeback 01, I believe. So we should see something coming in soon. Yeah, here it is. Ridgeback 13 goal reached. The job was task status succeeded, so it was done. You can see that the task is 0. The task was 1 and the current task is 0, so it's completed. And the job manager was called with a job completion callback. And you can see already it's assigned the following or the next job. So here you can see one of the jobs that was completed was removed from the job list because it's no longer there. It's completed. And it's already executing job 004 now. And yeah, that's pretty much it. So I'll shut down everything. Yes, I want to quit. And in here we can click shutdown, which will shut down everything that was being launched. As soon as that is done, so Gazebo always takes a little bit of time to shut down. There we go. So now that's all done. we can see that we have access to the buttons again, to the GUI. We can click whatever we want to launch, change the robot launch list, and then launch again. Or instead, quit application. And yes. So that was the demo. I hope it was, yeah, I hope it was helpful for you. And yeah, thank you for watching.